In this video, we are going to be looking at a concept known as the expected value. All right, so we're just going to jump really right into this. What the expected value is a criterion for comparing alternative decisions in the face of uncertainty. All right, it is also just the mean. All right, so the expected value is the same as the mean. All right, it's just doing the math slightly differently. All right, and really we're going to do it with these probabilities, which is going to make sense in a little bit because that's going to be kind of how the formula is created. Right, but we're going to use it for kind of when we have these probability statements. That's what it's designed for. All right, but again, it is a criterion for comparing alternative decisions in the face of uncertainty, and it is the mean, right? All right, so let's talk about how to find the expected value. All right, so for a discrete random variable, the expected value is given by the following formula. All right, so the expected value of our x is equal to the sum of xi times p xi. All right, where pxi is just a shorter way of writing the probability x equals xi. And I guess technically this should be a capital X. That's a terrible X, but that's okay. All right, so essentially we're saying, all right, if we don't know kind of anything other than this probability distribution, that's all we've got, all the information we've got. All right, the value we would expect our random variable to take is given by this value. All right, so the sum of xi, so again, these xi's, these are our possible outcomes, right? So the potential outcomes, right? And then we're going to multiply them by their associated probabilities, right? So we're going to, again, we're going to have our outcomes and the probabilities. They're going to be in pairs in a distribution table. So we're essentially just multiplying each pair together and then adding them up. All right, and of course we're going to do an example here in just a second. All right, but this is how we would do it. All right, we take the first outcome, multiply it by its probability, then we'd kind of put that to the side, take the second value, multiply it by its probability, right, and then start adding them together after we've multiplied. All right, one last thing, just want to write this down really quick. Just to have it kind of in a visual format. The expected value for our random variable x is the mean. All right, so the expected value is the mean. That's going to be important later on, so I want us to go ahead and get that down. The expected value for a discrete random variable, right, x, is equal to the mean. All right, now let's look at an example. All right, so let's go to something we've already looked at, all right, which is the kind of number of cases that Matt prepares. We've already got that probability distribution, so we're going to go ahead and use it again. All right, so we've got all of our, and this was from the last video. All right, so we've got our probability distribution, all right, our discrete probability distribution. So now we can actually calculate the expected value. All right, so the expected number of cases prepared in a day is equal to the sum of xi times pxi. All right, that's just the formula, we know that. All right, so then when we go to start calculating this, again, we're just going to take, all right, we've got 5 pairs of a outcome and the probability of that outcome. So we're just going to be taking each of those. So 0, all right, we're going to take our first outcome, multiply it by its probability. All right, then we're going to add to that the second outcome times its probability. All right, so on and so forth until we've done this for each value. All right, once we've done that, all right, we could punch these into our calculator kind of one at a time, or we could put them in all at once, depending on, really depending on your calculator. All right, but once we put all of these through here, right, and taking it to the third decimal place, we're going to find an expected value of 1.518. All right, so the expected number of cases for Matt to prepare in a day is 1.518, right? Or it's the expected value for the number of cases Matt prepares in a day. All right, but will Matt ever prepare exactly 1.518 cases in a day? All right, hopefully we said no, right? Because we know that this is a discrete random variable, right? We also know from the last video that Matt never starts to prepare a case without finishing it, right? So there are no half prepared cases, right? And also when we look, these are the possible outcomes, right? 0, 1, 2, 3, and 4, right? 1.518 is not in our probability distribution, right? So why is this the expected value if we can never actually get this value? Right, what the expected value is telling us is that if we repeat this random process, if we repeat this experiment over and over and over again, right, and then we took the result of all of those multitude of trials, right, or iterations of this experiment, and we took the average, right, the higher your sample size, the more times you've done this experiment, the closer it's going to get to 1.518. Right? On any given iteration of this experiment, right, it could take any one of these 5 outcomes, right? It could be 4, it could be 2, it could be 3, could be 0, so on and so forth. But if we do it enough times, we record the results and then we average those results, those are going to move towards 1.518, right, as we keep doing it. All right, that's what that expected value is telling us. It's not guaranteeing that we're going to that Matt's going to, prepare 1.518 cases every day, right? We can tell just by the probabilities over here that that's not the case, right? That he's not going to do that. So, all right, but that is an important thing to note, right? Matt will never actually get right there, right? But well, just lost my train of thought. Oh, right. So Matt will never actually prepare 1.518 cases, but again, over time, over multiple iterations, that's what the average of the outcomes for his trials will be. All right. All right. So let's take a look at another example. All right, for this one, we're essentially going to ask the question, right? How much should I pay for health insurance? Or just any insurance in general, I guess, really. All right. So what we're about to do is an extremely simplified version of what actually happens when kind of insurance companies are determining your premiums. All right, so let's say that we know our healthcare costs without insurance. All right, so this is what it's going to cost us in healthcare if we go, let's say, a full year without insurance. All right, so we've got our X, that's our healthcare cost, and then we are going to have our probabilities. All right, so let's say that you have 0 healthcare costs. All right, with a probability of 0.75. All right, so it's you don't get in trouble, you don't get hurt, you're absolutely fine. All right, then with a probability of 0.15, we'll say that you have insurance costs of $1,000. All right, and then for probability of 0.075, you have insurance costs, or healthcare costs rather, of $10,000. And then finally, with a probability of 0.25 or 0.025, you have healthcare costs of $100,000. All right. So again, kind of, these are the potential ones. And of course, this isn't exactly how it works, but we're simplifying things, right? So we can actually do this, right? So let's say, all right, so how much should I pay for health insurance? Or, should I get health insurance at all? All right, well, one way that we could find this out is by comparing our healthcare costs without insurance, right, or the expected value of our healthcare costs without insurance to what it's going to cost me to buy insurance, right? So let's say that instead of how much should I pay for insurance, we can answer that question in a second, right? But let's say that insurance for a year costs, and this is probably not even close to being real, but these numbers aren't real anyways. Let's say that health insurance costs $4,300 for a year. All right. Now we have one alternative. We have 2 alternatives, right? We could not buy health insurance, and kind of risk it, or 2, we could buy the health insurance. All right. So how we find out, right, or how we might try to determine which one we're going to do is we might look at the expected value. All right. So we can find the expected value of our healthcare costs. All right, we're going to do exactly what we did in the last example. So we're going to take each of these pairs of outcomes and probabilities. So that first one is 0 times 0.75. Then we're going to have 1,000 times 0.15 plus 10,000 times 0.075. And then finally 100,000 times 0.025. All right, so once we have done that, all right, we punch all of this into our calculator, and we're going to see that our expected value for healthcare costs without insurance is $3,400. All right, and so then the kind of questions become: should you get health insurance? All right, if your expected healthcare costs, right, or the expected value of your healthcare costs without insurance is $3,400, and insurance costs $3,400. I shouldn't have made these so similar. $3,400, and the insurance costs are $4,300. All right, so this is a little bit of kind of free economics, I guess, but kind of the theory states that you should be willing to buy insurance for up to and including the amount, your expected value. All right, so if somebody was charging $3,400 or less per year for insurance, right, theory would say you should get the insurance. Right. However, if the insurance cost is greater than that, right, you would not get insurance. All right. Now that's a very kind of simple, very basic way of looking at it, but there are some other factors that are involved, but again, that is essentially what's happening. All right, and this expected value thing right here, all right, this is essentially what an insurance agent is going to do when you try to get insurance. All right, obviously it's going to be a lot more complicated than this, right? Because what they're going to be doing is essentially calculating these probabilities for the different costs based on all of their characteristics, right? What your gender is, do you smoke, how old are you, right? Level of activity, all that kind of stuff, all right? Those are going to change those probabilities, all right? That's going to give them the expected value of what they're going to have to pay, right? Because if you have insurance, then the insurance company is picking all this stuff up, right? And so whatever that expected value is essentially what they're going to charge you in premiums. All right. But yeah, that is essentially it. So again, all right, go one more example, but we might just not worry about that because we're already at about 18 minutes in this video. All right. But again, expected value is a way for us to compare alternatives. But actually, we kind of do need to do that other example. We might just do, we'll see. Okay, anyways, all right. The expected value is a way for us to compare alternatives, right, when we have uncertainty, right? When we get the insurance, right, when we get insurance, that's a guarantee, right? That's a guaranteed, right, $4,300 we're going to pay every year, right? Without health insurance, right, you've got an expected value of $3,400 for your healthcare costs, but again, just like with the number of cases Matt works, right, that's not a guarantee, right? That's not saying that these will be or even that you should expect that to ever be your healthcare costs, because again, right, that's not one of the options. That's not one of the possible outcomes up here, right? But what we're saying is that as you go through year to year, right, and assuming these costs don't change, right, then your healthcare costs, the average of your healthcare costs over the number of years that you kind of have this probability distribution, right, then the average would be $3,400 a year, right? But right, again, the kind of the gamble you're taking if you don't get insurance is saying, well, the probability that I'll be fine is pretty high, right? And so if I'm fine, I don't want to have paid that $4,300 to get nothing back, right? But if you are just unfortunate enough to be in this, hit that probability 0.025 for the $100,000 in costs, right? You don't, if you get insurance, you don't want to be left kind of holding the bag for that one, right? And so that might be why you get insurance, right? But again, kind of those probabilities are going to determine that. All right, but this is expected values. In the next video, we might either look at that example I mentioned a second ago, or we're going to start looking at variance. All right, so expected value, that's the mean, right? When we do the mean, we usually also do the variance. All right, so that's going to be coming up next. All right, that's another way for us to evaluate these different probability distributions or these different alternatives. All right, but that will be in the next video.